So here we're going to ask to find the dot product. So I'll write the formula. The dot product equals u1 v1, which is our 2x components, plus u2 v2. So this is the formula that we're going to use for all of these. So whenever they give us a vector, vector u is given by u1, u2, and vector v is given by v1, v2. So if we want to find our dot product, for number 1, we're going to follow the formula u1, v1, so 6 and 2. And we're going to add v2, u2, v2. So u2 is 3, v2 is negative 4. So then we simplify our expression as much as we can. 6 times 2 is 12. 3 times negative 4 is negative 12. So 12 minus 12 is 0. So for number 2, we are doing the same thing. So u is given by u1, u2. And v is given by v1, v2. So again, we're going to fill out the formula and plug in what they gave us. So u1 times v1, so 4 times negative 2. And then we're going to multiply our y components. 1 and negative 3. And then we simplify as much as we can. So 4 times negative 2 is negative 8. 1 times negative 3 is negative 3. And negative 8 minus 3 is negative 11. Okay, now number 3 is very similar. The only difference is here they give it to us in component form. But remember, component form, if you want to change it, they gave it to us in standard form. So if you want to convert it to component form, which looks like this, you can. Or you can just go with what they gave you by looking at the coefficients. Because remember, vector u is given by u1i plus u2j. So we can just look at our coefficients. So this right here is u1, this right here is u2. And same thing over here with vector v. The coefficient is v1, and the coefficient here, even though it's not there, is actually a 1 for j, so that's u2. So again, if you want to convert it to a component form, you can, but you don't necessarily have to. So if we want to find the dot product, we're going to follow the same formula. So we have u1 times v1, so 3 times negative 2, and we're going to multiply that by u2, v2, so 2 and 1. So when we find our dot product, 3 times negative 2 is negative 6, 2 times 1 is 2, and when we add those, we get negative 4. Alright, so here we are finding the angle between the two vectors. So the formula we're going to be using is the angle equals the inverse cosine of the dot product divided by the magnitude of u times the magnitude of v. Okay, so here we are finding the angle between two vectors. So we're going to look at number 4. Now these are kind of 4-part problems because we got to find the dot product, the magnitude of u, and the magnitude of v. I'm going to label the vectors v1, v2, u1, u2, depending on which vector we're talking about. So then we need to find the dot product. We're going to fill in the values. So -1 times 0. Multiply our x components, and we need to multiply our y components. So here we get 0, here we get 0, and 0 plus 0 is 0. So now we need to know the magnitude of vector u. So the formula is the x component squared plus the y component. And we take the square root of all of it. So we're going to just look at vector u here. So we have -1 squared plus 0 squared. So -1 squared is 1, 0 squared is 0. So we get the square root of 1, which is just 1. Now we're going to do the same thing for vector v. We're going to find its magnitude. So we're going to take our x component, square it, our y component, square it, and we're going to take the square root of all of it. So the x component is 0, the y component is 2. So 0 squared is 0, 2 squared is 4. So we get the square root of 4, which simplifies to 2. So now to find the angle, we take the inverse cosine. And we basically plug everything into this formula over here. So we're going to plug in the dot product in the numerator, which we found was 0. We're going to take the magnitude of u, which was 1, and we're going to multiply it by the magnitude of v, which was 2. Okay, so if we type that into the calculator, we have the inverse cosine of 0 over 1 times 2. We get 90. So the angle between these two is 90 degrees. Okay, so here we're finding the magnitude between these two vectors again. So I will copy the formula over. For some reason, didn't put the dot product on there. Okay, so first thing we want to do is we want to find the dot product. Now, we can convert these to component form by looking at the coefficients. Okay, so we convert this to component form, so we're looking at the coefficients, so 3 and 4. So the 3 is u1, the 4 is u2. And same thing for vector v. We can rewrite that in component form by looking at the coefficients, so -2, +3. And that's given by v1, v2. So if we look at our dot product, and we fill it out with what they gave us, we're going to multiply our two x components, which are 3 and -2. Add our two y components multiplied, so 4 and 3. So that's -6 plus 12, so we get +6. Now we're going to have to find the magnitude of vector u. So again, that is the x component squared plus the y component squared, and then we take the square root of all of that. So our x component of vector u is 3, and the y component is 4. So 3 squared is 9, 4 squared is 16. So we get the square root of 25, which simplifies to 5. Now for the magnitude of V, we're following the same formula, it's just we're going to be using this vector. So I'm not going to rewrite the actual formula again, but our x component is -2, our y component is 3. So -2 squared is 4, 3 squared is 9, and we add those together, we get the square root of 13. So now we have everything we need to plug it into the formula. So we're going to put our dot product up top, which is 6, times the magnitude of vector u, which was 5, times the magnitude of vector v, which was the square root of 13. So we want to find the magnitude, the angle, so we need to type that in the calculator. So we get 70.55, so we'll round it up to the nearest one decimal place, so we'll say 70.6 degrees. Okay, now number 6, we're doing the same thing. We are finding the formula, the angle between the two vectors. So I'll go ahead and write the formula real quick again. So it's the inverse cosine of the dot product over the magnitude of vector u times the magnitude of vector v. So we need to find our 3 pieces of information so we can plug it into the formula. So for the dot product, again we're given u1, u2, v1, v2. So we're multiplying our 2 x components, 2 times 0, and we're adding our 2 y components multiplied by one another. So here we get 0 plus 0, which is 0. So we want to find the magnitude of vector u. So I'm not going to write the formula again, but if you need to, you can refer to number 5 or 4. But we're going to take our x component and our y component, and we're going to square those. And then we're going to add them together and take the square root of all. So 2 squared is 4, 0 squared is 0, so we get the square root of 4, which is 2. So we're going to do the same thing with vector v. X component squared plus the y component squared, and then we take the square root of all that. So our x component is 0, y component is -3. So 0 squared is 0, -3 squared is 9, and if we take the square root of 9, we get 3. So if we plug everything into the formula, we'll be able to calculate the angle between these two vectors. So we're going to take the inverse cosine of our dot product, which was 0, and divide it by the magnitude of u times the magnitude of v. So we're going to type all of that into the calculator at once. So we get 90 degrees again. So our angle here is 90 degrees.